we start with this, but I'll let the full presentation immediately after this class. So this one, the environment and development, we are going to cap. This is what in my part. These are the areas that we will deal with. The concept of environmental resources, the biosphere resources, water resources in the biosphere, vegetation, and so on. But there will be an improvement on this by tomorrow. Okay. So we are going to start with the environment. That is what we will do today. Okay, what is the concept of the environment? Environment is defined as the circumstances and conditions, other physical conditions that surround an organism or group of organisms, or the social and cultural conditions that affect an individual or community. Those are the two definitions. Environment is constituted by the interacting systems of physical, biological, and cultural elements, which are interlinked individually as well as collectively in myriad ways. The physical elements include the space, the landforms, the water bodies, the climate, the soils, the rocks, and minerals that determine variable character of the human habitat, its opportunities as well as limitations. Then the biological elements include the plants, the animals, the microorganisms, and man, which constitute the biosphere. The cultural elements include the economy, the social, political, which are essentially man-made features, which go into the making of cultural millennia. So you have, the environment has the physical, the biological, and then the cultural elements. Basically, this is what's involved. So the environment is constituted by interacting systems of physical, biological, and cultural elements, which are interlinked individually as well as collectively. So the physical elements are the space, the landforms, the water bodies, the climate, the soils, the rocks and minerals, the biological elements, the plants, the animals, the microorganisms, and man. And then the cultural elements, which are the economic, social, and political, that are essentially man-made features. So what are the environmental resources? This includes the biosphere resources, which is the region of the planet where organisms live. Where organisms live is called the biosphere. It is a narrow zone on the surface of the earth where soil, water, and air combine to sustain life. Very soon we'll look at the diagram showing the interaction between the biosphere resources. The biosphere is characterized as an area that sustains all living organisms and the products of their activities. It plays a critical role in the maintenance of ecosystems, that is, the existence of species and their reciprocal interactions, as well as climate regulation. The biosphere is related to the lithosphere, the hydrosphere, and the atmosphere, which are all spheres of the physical world. The lithosphere is the world's solid outer layer, which contains rocks, sand, and soil. That is the lithosphere. Where you have the rocks, the sand, and the soil is the lithosphere. Various environmental conditions such as favorable temperature and moisture are needed for organisms to live on Earth. Energy and nutrients are also needed by the species. The biosphere contains all of the mineral and the animal interesting day for life. So look at this photograph now. You have the atmosphere. This is the biosphere. This is where the part of the planet where life exists is here. The atmosphere, which is there, the clouds. The hydrosphere, this is the water resources. The lithosphere or the geosphere, this is the rocks, the soil, the sand. All of this sustain life, sustain the biosphere. So without any of this, life could be very difficult to achieve. The water nourishes the sand, the soil. Then the atmosphere provides the gases that we need, we use that aid life, basically. You have the oxygen, there, the carbon dioxide, where that the vegetation uses to manufacture food. You have a lot of other gases there that sustain one form of life activity or the other. So these are the biosphere resources: vegetation, the animals, including the snakes, the dead animals in the lithosphere. The vegetation is thriving on the soil. Then the animals, some of them live in the water, the marine ecosystem. So it's a combination of these that sustain life. What are the biosphere resources? Okay, so what are the atmospheric resources? These include the wind, the water, the sunlight, and gases, including ozone and greenhouse gases. The atmosphere is made up of gases that are essential for photosynthesis and other life activities. So the atmosphere is a critical part of the water system, the water cycle, and an important reservoir for water and the source of precipitation. If there is no atmosphere, then there can be no rainfall. It moderates the Earth's temperature as well. So you see, the atmosphere is all of them they are very critical in the sustenance of life. The atmosphere is the one that provides the wind, the water, the sunlight, and the gases that we need for the synthesis and other life activities. It also provides the water. See, the water resource, water in the world is the world's most precious resource because the life of animals and plants depend on it. Most industries also require water for various applications. So the global economy depends on it as well. You know, water is the source of major transportation between countries, continents. Is the major source of water for transportation of goods. Is the major source of transport for goods and services. Most of the water on Earth is salt water. Glaciers are the major freshwater resource, while the most important source for human is the surface runoff found in lakes and rivers. That is the fresh water. Water resources in the biosphere. This is how water exists. You have saline water. The ocean water is 96.5%. The saline water is 0.9%. The fresh water is 2.5%. And out of this fresh water, you have groundwater and glaciers. Most of the water, fresh water is stored in the glaciers, in the iceberg. And then also about 68% is stored in ice form at the are the polar regions, while groundwater is takes that 30.1%. Surface water is about 1.2 or 12%. No, it's not two. Yes, 12%. No, 1.2% is surface water. Surface water is 1.2%. That adds up to 100%. Yes. So the surface water now, the surface water, the lakes is 20.0%. The ground ice, the ice and permafrost is 69%. After the surface water, then the atmosphere, the one in this thing, the atmosphere, the one head up in the clouds is 3.0%. The living things, the water that we have in our bodies, in the plants and so on. Okay, the living things take 0.29%, the forests 0.49, the swamps take 2.9, and then the soil moisture is this. So this is the water, the total water distribution in the biosphere, in the ecosystem, the total water. The one that is held up in the rivers, the saline water, the fresh water, the ones in the glaciers, groundwater, the permafrost, and the one that even me and you, the one we drink, the one we keep in our bodies, the one that the trees keep, vegetation keep to make them healthy and fresh. This is the distribution that you can see there. So vegetation resources. These are vegetation that are derived from forests and savanna and of immense importance to man, animals, and plants. Vegetation is a key component of ecosystem and is involved in the regulation of various biogeochemical cycles like water, carbon, and nitrogen. Vegetation provides habitat to wildlife and ecosystem services such as food and fuel, timber, cash crops, pulp, fruits, rubs, clothes, and many game reserves. Vegetation converts solar energy into biomass and forms the base of all food chains. Vegetation influences the energy balance at the Earth's surface and within the atmospheric boundary layers, often mitigating extremes of local climate. So these are the type of vegetation. You have tundra vegetation, the forest vegetation, the grassland vegetation, the desert vegetation. The tundra vegetation is a large flat region of North America, Europe, and Asia, which the subsoil is covered with permafrost, and it is about 1,500 feet deep. So this is what you have as the permafrost. I mean the tundra vegetation. It's a large flat region of North America. North America, look at it. The tundra has fewer trees with stunted shrubs, which include lichens, mosses, and sages. This is the vegetation that you find there. The soil is covered with permafrost. Winters are dry and very long, and the growth of plants is restricted. Examples of plants in the tundra vegetation include beeches, willow trees, junipers, mosses, lichens, and Arctic bluegrasses. catchfly, and poppy. So this is what you have there. The forest vegetation. Forest vegetation consists of many trees of numerous species which are more luxuriant than those of any climatic region. These trees form a layer of foliage that largely covers the ground and shows stratification with more than one layer. If you go to a forest, you see different layers. You have the what you call the suppressed. This is made up of seedlings and saplings emanating from fruits. The fruits that would fall on usually the fruits of some of the trees, the older trees that fall on the ground, they serve to regenerate the tree. Just like human beings or animals giving birth to children. The trees, the seeds from the trees or other forms of regeneration, they serve to replace the older genera when the trees are gone. So they form the under layer. Then you have another layer, which is made up of shrubs and climbers up to the topmost layer. So if you go to a forest, you see layers of vegetation. At different levels, you have vegetation. So this is a typical forest with its layered structure. So these trees form a layer of foliage that largely covers the ground and shows stratification with more than one layer. So you have different layers. The undergrowth, the shrubs, that is the ones that the shrubs develop, the undergrowth develops into shrubs. At the lowest level, you have the seeds, the seeds and the seedlings and saplings. Then the higher level, you have the shrubs. The shrubs, you have the climbers, the creepers. Then at the highest level, you have the older trees. So you usually have more than one layer in the forest. It is characterized by creepers, climbers, trees that are formed of huge buttress roots, and their experience of undergrowth. Yes, buttress are very large roots, those big roots from very old trees. So the buttress are those large root systems that sometimes taller than the height of some trees that the buttress arrangement is even taller than humans. So those are the kind of in a typical natural forest. Example of trees found in the forest vegetation include mahogany, the ashes, the willows, the maple, the beeches, mosses, lichens, rosewood, mangroves, and oaks. The grassland. Grassland vegetation is natural. It's a natural plant cover that is dominated by grass or grass-like vegetation. This grass-like vegetation has been formed by nature. It's not man-made. The grasslands are called by different names in different parts of the world. They are called steppes in Russia, downs in Australia, veld in South Africa, savanna in Central Africa, the prairies in North America, and pampas in South America. So that is what you have there. You also have the desert vegetation. The desert vegetation is a large dry area covered with sandy soil and rocky soil. The trees in this vegetation include short shrubs, which cover in patches and are characterized with thorns, thick stems, long roots, and wax-coated leaves and stems. So this is a typical desert environment. The vegetation is like what you see here, mostly very sparsely populated vegetation. The trees are short shrubs like this. Examples of plants in desert vegetation are cactus, date palms, this is date palms, acacia, honey bushes, and coarse grasses. Desert vegetation are sometimes made up of little or no plants and animals. It has high temperature and receives little amount of rainfall. An example of desert vegetation includes Southwest Australia Desert, Arabia Indian Desert, Sahara Desert, Atacama Desert, and Kalahari Desert. So those are the kind of environments that you have. Mineral resources. All these are environmental resources, so mineral resources. There are four main categories of mineral resources: the metallic, non-metallic, fossil fuels, and water. Metallic minerals are those that are composed of a metal or metal alloy, such as gold, silver, copper, and iron. Non-metallic minerals are a special group of metallic minerals are those that are composed of a metal or metal alloy, such as gold, silver, copper, iron. Non-metallic minerals are a special group of chemicals from which no new product can be generated if they are metal. Example, you have sand, gravel, limestone, clay, and marble. All these are non-metals. Mineral resources are important because they provide us with the raw materials used for building structures. Such as clay and steel from iron, and then electronics, such as copper, gold, rare earth elements, or tools. Fossil fuels and uranium provide us with energy and phosphates for enhanced agricultural production. Environmental resources management. Environmental resources management aims to ensure that ecosystem services are protected and maintained for future human generations by considering ethical, economic, and scientific variables. Environmental resource management tries to identify factors affected by conflicts that arise between meeting needs and protecting resources. So this involves the management of all components of the biophysical environment, both living, biotic, and non-living, abiotic, and the relationships among all living species and their habitats. Environmental resource management strategies are intrinsically driven by conceptions of human-nature relations. All human activities take place in the context of certain relationships types of relationships between society and the biophysical world. So the idea of environmental management is to organize resources which we use on a day-to-day basis that are derived from nature in such a way that we continue to use them, those resources for our daily needs, without destroying the resources. In other words, without compromising the ability of future utilization, including the utilization by even our children and the generations yet unborn. So you balance the utilization so that you can continue to have good air to breathe. You have continue to have good water to drink. You have continue to have good soil on which to plant your crops and to use for other very necessary applications without compromising the availability of future utilization. Because in most cases, uncontrolled exploitation of resources leads to depletion and leads to contamination, leads to pollution, and leads to destruction. So development cannot thrive without the utilization of natural resources or environmental resources. But good judgment requires that as we use these resources, we should have in mind that the resources will be needed on a daily basis, and that they will not be destroyed. They can only remain available if there is careful utilization and protection. So I'm going to stop here today, okay? So that I will arrange this, I'll stop here and arrange this course, because I have to look for the other material that I made. So that will be better handled tomorrow. So tomorrow we're coming, I'm sure of that topic that we have treated. So I don't want to jump into other things. I will stop here, work on the other material, look for where it is, and then tomorrow we will continue. Is that okay? Hello?
Yes, sir. It's okay, sir.
Yes,
we have an afternoon class too, sir.
Yes, that is with the center leader. So
okay, sir.
Yeah,
okay.
You can work with her in the afternoon. So we will continue tomorrow morning.
Yeah. Your hand is up.
Okay, Sesu, yes. Yes, I'm hearing you.
Sesu, you can speak. You can unmute and speak, sir.
Hello?
Sesu, unmute yourself.
Yes, I've done that.
Yeah, go ahead.
Hello, sir. Can you hear me?
Yeah, I'm hearing you very well.
Okay, sir. Thank you for the wonderful presentation. I have a question that I need you to help me with. And in the forest ecosystem, now,
yes,
the trees and the shrubs are just as environmentalists differentiate between a shrub and a tree. That is when they are growing up at tender age. And how to identify between the shrubs and the tree. Sometimes they look the same. So how do I know that this one is a shrub and this one is a tree?
Okay, usually the size and the height will differentiate, and the nature of the leaves. The formation of the tree is not, it cannot be the same, just like a man and a child now. There's no way the trees will have, each species, each genera has its own growth pattern. And it has the younger elements, and then the older parts. So you will always see a differentiation. I don't think it's possible for species to just look the same. Age has a way of telling which one is older and which one. The shrub will develop from the seedling or the sapling normally, and then it's the same shrub that will become a tree. A shrub is not necessarily a tree until it has grown to about 6 meters. Okay, so a shrub is within about 3 meters, between 2 to 3. Then the saplings are the ones that are just picking up on the ground, between 0 to 1 meter. So apart from that, you have the development of the leaves and the size of the bowl. So these things they are actually, it's easy to distinguish between the saplings, the saplings, the shrubs, and then the mature trees. It's very, I don't think there is any ambiguity about that. Hello? Sesu? Hello? Hello?
So we can hear you. We can hear you, sir. I think
I'm done. No. That is what I wanted to say. That is good to,
I think you've heard you
there's
very
no
clear.
ambiguity about that. Hello? There's
No,
no
I said I think
ambiguity
Mr. Fish heard you loud and clear. Any other person with a question, just raise up your hand and
yes,
we
it's a
will
question
ask.
time. Okay, in the absence of any question, then we can post now.
Yes, sir. Thank you very much, sir.
So sorry for all this.
No, it's not a problem.
Tomorrow we'll be with you. We'll be fully on ground.
Yes, sir. It's not a problem. You built even the knowledge we've had from the 30 minutes earlier.
I went all thinking that is what we're doing.
Wasted, sir. Yes, sir.
Okay, so thank you.
Thank you, sir.
Bye bye.
Let's greet Prof.
Thank you very much.
Yes, sir. Thank you,
Prof. Thank you, sir. Thank you, sir. Thank you. We appreciate. Thank you, sir. Thank you, sir.
See
you tomorrow. Thank you, sir.
100 and something. Okay.
Yes, thank you very much. 150.
I hope that your exam questions will be simple.
Thank you very much, sir.
Yeah,
thank you, sir.
Thank you.
Thank you, sir.
We love you, sir.
Thank you.